Okay, here is our first lesson of Unit 3 on the exponent laws, which should be review, but we can go over it again. We're looking at exponents, so we have the base here is 3 and the exponent is a 4, so the entire thing is called a power. What does 3 to the 4th mean? It means that 3 is multiplied by itself 4 times. So 3 to the 4th is 3 times 3 times 3 times 3. That is expanded form. How do we read 3 to the 4th? It is read 3 to the exponent 4 or 3 to the 4th, but never 3, 4, because that kind of suggests that you're just multiplying 3 times 4, which isn't correct. So some rules that you've seen before. The rule for multiplying powers. If we multiply powers that have the same base, we add the exponents. So you'll notice here in example 1, the bases are both 3's. So when that happens, it kind of saves us time. If we can just say that 3 squared times 3 to the 5th, if I add my exponents up, that's 3 to the 7th. This saves me time because on my calculator then, hopefully you have a scientific calculator, or you can use a scientific calculator online, or your phone, I guess, if you turn it sideways. We need to do 3 to the exponent 7, which is not 21. So 3 times 3 times 3 times 3, 7 times, right? So our answer there is 2,187. Here I have the same base. So this only works, this trick works if you have the same base. -2 is the base, so I can add my exponents because I'm multiplying. -2 to the exponent 6. Since I have an even number of multiplications, I know my answer is going to be positive, and I get 64. If you just type in -2 to the 6 on your calculator, it might give you -64 if it's not doing that correctly. Since we have brackets, it means -2 times -2, so you would have 6 negatives, and that should give you positive 64. Division. So something else you've learned, I think, is that when you divide powers that have the same base, you can subtract the exponents. So it saves us time. We don't have to find, like I really don't want you to find 6 to the 5th and what, or -6 to the 5th and what -6 to the 3rd is. I would like you to subtract the exponents. So that gives you -6 to the exponent 2. But -6 times -6 is 36. So sometimes you don't need a calculator if you do it that way. I don't know what -6 to the 5th is, but I can do -6 squared in my head. So even if you have a variable, you would still subtract the exponents. So 3 minus 2 is 1. Usually we just write that as Q. And then there's one last rule, that is if the power has a power. So if your exponent has an exponent and they're right side by side, you multiply them. So I see here 5 squared to the 3rd. That would actually give me 5 to the 6th, not 5 to the 5th. I would multiply them when they're side by side like that. And then I am getting 15,625. Same thing with variables. If I have t to the 4th to the 3rd, that would be just t to the 12th. So you would multiply. Let's look at this one. Example 4. Okay, a few little things here. That exponent applies to the x as well as the y. So be careful there. That's x to the 3rd, y to the 3rd. And same over here. That 2 is an exponent of an exponent, or a power of a power. So you would multiply both of those. So that would be a to the 4th, b to the 6th. And then last page here. A few more things just to remember. When you have a fraction, the exponent applies to the numerator and denominator. So this 3, that means a to the 3rd and b to the 3rd. So you can kind of do them each separately when you have a fraction. So I would write that, since I just have variables, a to the 3rd over b to the 3rd. A little different when you have numbers in there. This is an exponent with an exponent, so they're right side by side, so we multiply them. So we would get x to the 12th But be careful in the denominator. This is also an exponent of an exponent here. So we would have y to the 8th. Now they don't have the same base, so you can't subtract. You would just have to leave your answer like that. A few more things just to point out. Here, multiplication, same base. We could add the exponents. Here, multiplication, same base, but there's a negative exponent. I would add my exponent. 3 plus -5 is -2. And tomorrow's lesson, we're going to talk about what to do with negative exponents. Here, be careful here if it's multiplication, -2. Oh, wait a second. You don't have the same base. So let's just leave that one as it is. There's no shortcut here. And let's just say that, no shortcut. You could still find that answer, but not with our little exponent rules that we're trying to use. Here I have the same base and it's division, so I would subtract the exponents. This one, I have the same base and it's division, I subtract, but be careful, 2 minus -5 means 2 plus 5, so that would be 7 to the exponent 7. And for all of these, I mean, we could keep going and find the actual answer, but we're just trying to point out some of the rules. Here you have an exponent of an exponent, so you multiply them, get 6 to the 15th. And then you could find the answer to that. This one, an exponent has an exponent, so we would keep our -5, and the exponent then would become -9, which we will learn about dealing with negative exponents in our next lesson. Last one. Remember BEDMAS. So exponents have to come before multiplication. So in this case, I'm going to leave the 3 because multiplication comes after exponents. 2 to the exponent third. 2 times 2 times 2 is 8. And 5 to the exponent third. So they both have the exponent of 3. 5 times 5 times 5 is 125. And when you're multiplying a number by a fraction, remember that these are the numbers that get multiplied together. So we could do 24 divided by 125. Okay, and then there's some homework. There's a homework sheet as well posted in this news item. I hope that made sense, and it's probably something you remember, I think.